Hey guys, today we're going to be dealing with real world applications of trig functions. So if you can turn to page 34 in your packet, we are going to take a look at number 69. Okay, so this was a part 4 on the Algebra 2 Regions 1 year. All right, so it says, the resting blood pressure of an adult patient can be modeled by the function P below, where P of T is the pressure in millimeters of mercury after time T in seconds. Okay, so this is P of T. This is the function they give us. Now it says, on the set of axes below, graph y equals P of T over the domain from 0 to 2. I'm just going to move this up a little bit here so I have a little more room to work. Okay, now they give us this function here, right? And I'm going to, off to the side, I'm going to write down a lot of our important information, and then I'll worry about having to graph it. All right, so let's just make a list. We usually like to find the amplitude, the frequency, the period, the vertical shift. You can tell by looking at the equation there's not going to be a horizontal shift, so I'll leave that out. And then I guess our min and our max. Okay, so when we look at this function right here, right, the amplitude is the number that's in front of the word sine or cosine. So here our amplitude is going to be 24. All right, the frequency is what is in front of our, usually x, but they're using a t, right? This doesn't say p of x, it says p of t. So in front of the t, we have a 3 pi. So that's going to be our frequency. Okay, so we know the formula for period, right, is 2 pi over the frequency. And since our frequency is 3 pi, I'm going to write 2 pi over 3 pi. And then what's going to happen is the pi on top cancels with the pi on bottom, and that just simplifies to 2/3. So the period is 2/3. Okay, now our vertical shift, right, is just this number right here. It's the number that's being added or subtracted to the end of a function. So this is going to be 120. And then the formula for min would be your vertical shift minus the amp. So since our vertical shift is 120 and the amp is 24, we're just going to do 120 minus 24. Okay, which is equal to 96. And then we know that our max is our vertical shift plus our amplitude. So 120 plus 24. Which brings us to, let me see if I can squeeze this in here, 144. Okay, so now that we have this, we can really set up our axes here. Now we know that the minimum value we're going to need is 96, and the maximum value we're going to need is 144. Now, see this right here? This is called an interval break. Okay, if you make a little jagged area, that means we're not using any of the numbers from 0 to 90. So you could number by whatever you want, as long as it fits to give us up to 144. Now, I'm thinking, let's just see, if we number by 5, right, if this is 90, let's just see if it fits. 95, 100, 105, 110, 115, 120, it's going to fit. 125, 130, 135, 140, 145, and we only have to go up to 144. So I'm going to jump by 5s along the y-axis, which is technically our P of T axis. I don't want to squish all those numbers, so I think I'm just going to skip 2 boxes and put 100. Skip another 2 and put 110. Make sure you're leaving the same amount of space in between each of these, labels. All right, so I guess I'm technically going to number up to 150. And if you go back up to the top of the page here, right, it says that P of T is the pressure in millimeters, so that's how I'm going to label this axis right here. Okay, so there we go. Now, this axis down here right? Didn't they say that t, let me pull it back up, right here, is the time in seconds? Okay, so this axis we're going to label time, and that would be in seconds. Now they do say that they want us to label it, they want us to graph in the domain from 0 to 2. So it looks like they jumped 1, 2, 3, 4, 5, 6 boxes to put the 1. So another 1, 2, 3, 4, 5, 6 boxes would bring us to the end of the graph, which is at 2. So there we go. Okay, so now let's see what else we can do before we start graphing. Now the vertical shift right here is important to us, right? That's always where our midline falls. And I like to put a dotted line there. So at y equals 120, let's put a dotted line. That's where the middle height of our graph is going to be. That's our midline. Okay, and if we look at our information here, right? See right here where it says the period is 2/3. That tells us basically the horizontal length of one cycle. So once we hit 2/3, we're going to finish. We're going to have completed one cycle. So if this is where 0 is and this is where 1 is, maybe let's break this up into thirds, right? Because we have to figure out where 2/3 falls. So we said that there's 6 boxes. So if you take 6 boxes and break it into thirds, right? 6 divided by 3 would be 2. So every 2 boxes would represent 1/3. So this would be like 1/3. 2 more boxes would be 2/3. This would be 3/3, which is 1. Then 2 more boxes would be 4/3. 2 more boxes would be 5/3. And then 6/3 would be here, which is 2. Okay, so now that we have our graph all set up, let's graph it. Okay, so we know that we have a cosine curve, right? So a cosine curve looks like this. It starts up high, drops all the way down to a minimum, and then ends off back high. Okay, so the midline is somewhere right there in the middle of it. So if this is our graph, right, we know the period is 2/3. We have to fit one complete cosine curve between 0 seconds and 2/3 seconds. So at 0 seconds, right, we're going to be at our maximum height of 144, which I'm going to put right here. And then since the period is 2/3, once we hit 2/3, we're going to be at that last point in our cosine cycle, which is right here. Now we know halfway between our 2 maximum points, see right here, halfway between our 2 maximum points, we meet in the middle and we're down at a minimum. So if I go 2 boxes from this first point or 2 boxes to the left from that second point, I'm going to be all the way down at my minimum, which we said is 96. Okay, so when I meet in the middle, I'm going to be all the way down at 96, and that's where I'm going to put a point. Okay, so right there. Okay, so now that we have those 3 points, we have 2 more to go for this cycle. Okay, if you recall, let me just move this down a little. If you recall, remember every cosine or sine cycle has 5 points. So for cosine, we have 2 maximums, which we already plotted, 1 minimum, which we already plotted, and then halfway between any maximum and any minimum, we are going to be on that midline. So we have 2 points on the midline. So all we have to do is plot the 2 points within the cycle that go on our midline. Okay, now when I say halfway between, what I mean is if we look at this maximum and this minimum, okay, if we were to move over 1 box from the maximum and move over 1 box from the minimum, we would meet right here in the middle. So right here, we're going to be on the midline. Okay, and same thing, if we go to this maximum and move to the left 1 box, and if we go to this minimum and move to the right 1 box, okay, we're going to meet right here in the middle at the midline. So this right here, I'm going to connect it. This right here is our first cycle of this cosine curve. Okay, so they want us to graph it over the interval, right? The domain from 0 to 2. We only went from 0 to 2/3. So we need to graph another complete cycle, which will bring us to 4/3, and then a third complete cycle, which will bring us to 2. So we're basically going to do the same thing 2 more times. Okay, so let's start our next cycle. So in the next cycle, right, we're going to have this right here would be the beginning of our next cycle. Now, the next maximum, we know since the period is 2/3, once we go 2/3 more boxes, right, 2/3 plus 2/3 will bring us to 4/3, we're going to be up here at our next maximum. Let's put a point. Oh, let me go back to pink. Let's put a point right there. Now, midway between any two maximums on a cosine curve, we're going to be all the way down here at our minimum, which we said was at 96. I'm going to put a point right here at 96. And then again, halfway between any maximum and minimum, we're going to meet in the middle and be on that midline. Okay, same thing here. From this minimum, if I move over 1, from this maximum, if I move over 1, I'm going to meet right there in the middle and be on that midline. So this is our second cycle, and we're going to need to make one more in order to use this given domain. Okay, so again, here's the beginning of our third cycle. The end of the third cycle will be 2/3 boxes over, right, which brings us here. And then just follow the symmetric pattern. Midway between these two maximums, we're going to be all the way down at a minimum. And then we know that we're going to have these 2 points on the midline. And there we have it. Okay, there is our curve. So we have 3 complete cycles on this given domain. And I'm just going to label the graph. You could write the whole entire equation. I'm just going to write P of t. If you want to write the whole thing, you can. That's up to you, but I'm fine with just P of t. All right, so let's see what we have done here. All right, so first thing, determine the period of P. Okay, well, the period, we already did that up here, right? See with that period? Let me move this down a little. The period is equal to 2/3. So we could just write that out. I mean, we've already shown the work above, or by looking at the graph, right? The period, the horizontal length of one complete cycle. So from here all the way down to the end of the cycle is 2/3. All right, so period equals 2/3. I'm just going to abbreviate. Now it says to explain what it means in the given context, so in terms of what this problem is talking about. Okay, so let's think about it, right? The period's 2/3. It takes 2/3 of a second for the graph to go from this maximum point to the next maximum point. And if you want to think about what, these maximum points represent, you may want to go back and just reread what the question is asking. I actually, you know what I did? I looked at the next part, and they were talking about down here, blood pressure oscillates between a maximum and a minimum. So it looks like what happens is your blood pressure has, when you're given a blood pressure reading and they say, for example, right here, 140/90, the bigger number is going to be the maximum value it reaches, and the smaller number is going to be the minimum value it reaches, right? So if we look at our graph, the period right here, 2/3, represents the time it takes for the blood pressure to go from one maximum reading all the way through to the next maximum reading. Okay, so this is what I said. It takes 2/3 of a second for the blood pressure to oscillate, I stole that word from this right here, from one maximum to the next. Okay, so it takes 2/3 of a second, basically, for the graph to go from one maximum all the way down to the minimum and back up to the next maximum. All right, so the last part says normal resting blood pressure for an adult is 120/80. This means that the blood pressure oscillates between a maximum of 120 and a minimum of 80. Adults with high blood pressure, above 140/90, and adults with low blood pressure, below 90/60, may be at risk for health disorders. Classify the given patient's blood pressure as low, normal, or high, and explain your reasoning. Okay, well, if you look, I'm not going to scroll back up, but if you look at the graph, right, our maximum value was 144, and our minimum value was 96. So we could say that as 144 over 96. Okay, the same way they're saying it here, right? 140/90. 90 over 60. So they want us to classify this as low, normal, or high. All right, well, if you look at these numbers, right, these numbers are above 140 over 90. So this patient would be classified as having high blood pressure. Okay, so you could just put that into words. So I said the patient has high blood pressure because 144 over 96 is above 140 over 90. All right, and if you can flip to the next page in the packet, we're also going to take a look at number 70. So number 70 says, each time your heart beats, so this one is again about blood pressure, you could see. Each time your heart beats, your blood pressure first increases and then decreases as the heart rests between beats. The maximum and minimum blood pressures are called systolic and diastolic pressures, respectively. A reading of 120 over 80 is considered normal. Okay, so a certain person's blood pressure is modeled by this given function. And it says where P of T is the pressure in, this would be read as millimeters of mercury, that's a symbol for mercury, at time T measured in minutes. All right, so first thing they want us to do is they want us to find the period and explain what it means in the given context. All right, well, by looking at an equation, right, the period isn't built into the equation, but we do know that period is equal to 2 pi over the frequency. So if we look at the equation, right, we're going to do 2 pi divided by, now the frequency is what's in front of your x. Now in this case, instead of using an x, they use a t, so it's what's in front of the t, which if you look in front of the t, it says 160 pi. And then all we're going to do is simplify this. So the pi on top cancels with the pi on bottom, and 2 over 160 we just simplify to 1 over 80. Okay, so 1 over 80 is our period. Now they want to know, what does that represent in the context of the problem? Okay, so when you go back and read it, it is talking about blood pressure, but it says each time your heart beats, it describes what happened, right? Your blood pressure increases, then decreases. Now, the period is representing how long it will take for your heart to beat. So basically this 1 over 80 means that it takes 1/80th of a minute for your heart to beat, okay? In other words, your heart beats 80 times per minute. But if you want to, use this number 1 over 80, it really just means your heart beats every 1/80th of a minute. Okay, so there we go. You just put that into words. So then part B, find the number of heartbeats per minute. Okay, so we just kind of said that, right? If your heart beats every 1/80th of a minute, that means your heart is going to beat 80 times per minute. So there we go. Okay, so in the next part, they want us to graph P. Now, they don't say how many cycles, they don't give us a domain, so that's really going to be up to us. So let's first, I put the equation here. Let's write down all of our important information. Okay, so just like the last question, let's write down what our amplitude would be, the frequency, the period, vertical shift again. There's no horizontal shift. If there was a horizontal shift, it would be a number being added or subtracted within the parentheses. And then our vertical shift, after that we could put our min and our max. That lets us know how high and low we have the number on the y-axis. Okay, now I just want to point out the way this equation is written, instead of having this 115 being added to the end of the equation, they have it in the beginning. But whether the 115 is in the beginning or at the end, right, it means the same thing. This 115 is your vertical shift, the number that's being added or subtracted to the actual function itself. So 115 is going to be our vertical shift. I'm going to actually skip ahead and put that there. Our amplitude is this number right here that's in front of the word sine. So the amplitude is going to be 25. The frequency, we already talked about frequency and period above. The frequency is what's in front of the t, so the 160 pi. And we already found the period above to be 1/80th. So I'm just going to write that down. We don't have to show the work. We already did that. And we know that our min is equal to your vertical shift minus your amp. So 115 minus 25, which is 90. And we know that the max is equal to your vertical shift plus your amp. So 115 plus 25, which is going to be equal to 140. Okay, so this is the min and this is the max that we're going to need to include on our y-axis. So since we don't have to include any numbers less than 90, if you want, you can do what they did on the last question. You could make kind of like a zigzag on the y-axis here and make what we call an interval break. So I'm going to actually do that. I'm going to just kind of make a little zigzag like this, and that's my interval break. Okay, so then what I do is I start numbering at 90. It looks like I'm probably going to have to skip by tens maybe to fit all the way up to 140. So let's see, so then this would be 100. This would be 110, 120, 130, and 140. Okay, and we also have to label our y-axis here. So if you read above, it looks like P of T represents blood pressure. So let me put that. Sorry, I'm kind of writing this sideways to squeeze it. This is a little messy, I'm sorry. And then that's an S. And don't forget to put your units, which is millimeters of mercury. Sorry, I was kind of squeezing that in there. All right, while I'm at it, let's label the x-axis as well. So we know the x-axis is going to be time in minutes. Okay, now nowhere does this question tell us how many, cycles they want us to graph. I'm just going to graph one cycle. So let's think about it. If the period is 1/80th, that means it's going to take us 1/80th of a minute, right, for the heart to beat. It's going to take 1/80th of a minute to complete one cycle. So like along the bottom, you could put 1/80th wherever you want. I would just skip, usually we try to skip an even number of boxes. So I'm going to jump, let's see, think about a cycle, right? It has a total of 5 points. So first point, skip a box, second point, skip a box, third point, skip a box, fourth point, skip a box, fifth point. I'm just going to literally put 1/80th right here. So let me label that as 1/80th. Okay, that's my period. If you want to label other numbers, you can. That's up to you. If you want to maybe label the halfway point right here. 1/80th divided by 2 would be 1/160. But if you're not sure about that, I wouldn't put that. I would just label. As long as you have one unit on there, it's assumed that everything else is spaced out properly. Okay, so now let's graph this. Now we have, let's see, we have a sine curve, okay? So we know it's going to start on the midline. Well, the midline is at y equals 115. So let's put a dotted line at y equals 115 right here. Okay, so there we go. There is my midline. Now we know the sine curve has 3 points, right? If this is your sine curve, it has 3 points on the midline. The first point, the last point of the cycle, and the middle point of the cycle. So on that midline, we're going to put our first point on the midline. Since the period is 1/80th, we know that's where our cycle is going to end. So I'm going to put the last point of our cycle there. And then if we meet in the middle, right here at 1/160, that is going to be another point on our midline. So far we graphed this point, and this point. Now we know midway between these 2 points, we're going to meet in the middle and go up to a maximum. So midway between these 2 points, that's where we are. We're going to go up to the maximum, which we said is 140. So there's going to be a point right here at 140. Okay, and then midway between these 2 points, we're going to meet in the middle, and we're going to be down at a minimum, which we said was 90. Okay, and this right here is our function P of T. If you want to graph more cycles, you can, but it doesn't tell us to. So I would, sometimes more is less, right? Because you could wind up losing points if you make a mistake. So I'm going to leave it at that. Okay, so then it says in part D, find the blood pressure reading. So when we do a blood pressure reading, we take the maximum value and put it over the minimum value. So you could either say 140 over 90, like that. Or if you want to put it in words, you could say 140 over 90, whichever you prefer. Either one of those, just put or. Either one of those is fine. So then it says, how does this compare to normal blood pressure? All right, so let's go back up to the very beginning of the problem. I'm actually going to take this and scroll up to the beginning. All right, so it says a reading of 120 over 80 is considered normal. So 120 over 80 is considered normal. Now let's look at what we have. We have 140 over 90, so this is higher. So this person, I would say, has high blood pressure because it's higher than the normal reading of 120 over 80. Okay, so there we have it. This person has high blood pressure because normal reads 120 over 80.